Alright, so still with the synthetic division, again, you want to always make sure that your polynomial on top is in descending order and it has no missing terms. And notice that this one does have missing terms and it is not in descending order. So the first thing I want to do is rewrite this in descending order. And so I'm going to start with my 9x to the third, and then I'm looking for my x to the second. I don't have one, so remember you add a 0, x to the second, and then I have negative x, and then I have a positive 5. So I have it in descending order. I have x to the third, x to the second, and x to the first, and then my number. The missing term was added, and now we're ready to start. So I want to take what's with the x, and it's a -2, and I do the opposite of that, which will be a +2 in a backwards L. So opposite of -2 in a backwards L will be +2. Then I take the numerical coefficients that's in my polynomial above, and I'm going to write it right beside that 2. So I'm going to have 9, 0, -1, and 5. I'm going to write or bring down my 9 first and multiply. 2 times 9 is 18. Add down and I get 18. 2 times 18 is going to be 36. When I subtract down, I get 35. 2 times 35 is going to be 70. And when I add down, I get 75 as my remainder. Okay? Now this looks crazy, but it doesn't really matter. We just want to put it in polynomial order or polynomial form. So we want 1 degree less than what we started with. So since we started with x to the third, I want this to be 9x to the second plus 18x plus 35. Notice it just goes down in descending order. So if I start with x to the second, this will be x to the first. This will be my constant term. And then my remainder will be 75 over x minus 2. Okay, so this is my polynomial form of this particular quotient. All right. So the next thing I want to do is the next problem. Again, you want to make sure that you're in descending order. I have x cubed, x to the second, x to the first, and then my number, so everything looks good. And then I'm going to make sure there's no missing terms, there's not. I want to put what's with the x, that +3 in a backwards L, so it's going to be a -3. And then I'm going to write my numerical coefficients down. So I have 4, 11, -8, and -10. Bring down my first term, and my first term is a 4. I'm going to multiply. -3 times 4 is -12. When I subtract, I get -1. -3 times -1 is +3. When I subtract down, I get -5. -3 times -5 is +15. When I subtract, I get 5. And this is my remainder. So I'm going to write my answer in polynomial form, 1 less than the degree that I started with. So it's going to be 4x to the second minus, you don't want to put 1, just put x minus 5, and then my remainder, 5 over that denominator, x plus 3. And that is in simplest form. And I'm just going to slide this up when we switch pages. Okay, and we're going to start with our x squared minus 49 over 8x minus 7. So here we have in descending order, but we don't have we do have missing terms. We don't have our missing terms inserted. So I'm going to insert those missing terms. A squared plus 0a minus 49. And remember, I just added a 0. I want a to the second, a to the first, and then my number. Whatever's with the a, I want the opposite of that in a backwards L. So 7 in a backwards L. Then I'm going to write my numerical coefficient. So remember, there's an understood 1 in front of the a squared. Then I have a 0. Then I have a -49. I'm going to bring down that first term, that 1. And I have 7 times 1 is 7. 0 plus 7 is 7. 7 times 7 is 49. And when I subtract, I get 0. And this is my remainder. Now remember, polynomial form is 1 degree less than what you started with. So I started with a to the second. So this is going to be 1 a to the first plus 7. And that's my answer in simplest form. Okay, we have one more example. And we'll be done with our polynomial division. And so this one, of course, is not in inserted missing terms. It is in descending order because I have it from biggest to smallest, but I'm missing a couple of terms. I don't have my x squared, and I don't have my x to the first. So I have to put a 0 for my x squared, a 0 for my x, and then I can write my 64. I'm going to start with my number plus 4. I'm going to do the opposite of the plus 4, and I'm going to do a minus 4 in the backwards L. And then I write all my numerical coefficients down. So I have 1, 0, 0, and then 64. I want to bring down that first number 1 and multiply. Negative 4 times 1 is negative 4. I'm going to add down and get negative 4. Negative 4 times negative 4 is positive 16. When I add down, I get 16. Negative 4 times 16 is negative 64. And when I subtract down, I get a remainder of 0. So to write my answer in polynomial form, I'm going to go 1 degree less than what I started with. So this is going to be 1x squared minus 4x plus 16. And I don't have a remainder, so this is my answer in simplest form. I know polynomial division is difficult. I hope that you have gotten the hang of your synthetic division. If there's more examples you need to see or me explain something better, please let me know, and I'll be happy to work more examples for you.